Hello, everyone, and welcome to Lab 2. In this week's lab, we will be performing 3 different experiments. All 3 experiments should be able to fit on one breadboard, as shown here. Be sure to allow space for all 3 experiments when wiring. For our first experiment, we will use an LED to observe how photoresistors operate. For this experiment, you will need your breadboard, jumper cables, an LED, and a photoresistor. Photoresistors are light-sensitive resistors. Their resistance value is dependent on incidental light, as we will now observe. If you move your hand in front of the photoresistor, you will notice that your LED light will dim or turn off completely. Photoresistors are often found in applications such as streetlights, alarm clocks, and guitar amplifiers. This concludes Experiment 1 of Lab 2. In Experiment 2, we will program our Arduino board to control the buzzing sound from a piezo buzzer, like this one. Your Arduino board is a microcontroller that allows you to not only power your circuit, but communicate with your breadboard via computer. If you follow your assignment sheet, your piezo buzzer setup should look like this. Note that the longer jumper cable is connected to the Arduino board as per the assignment. The Arduino code for this assignment is shown here, and is also included in the Lab 2 assignment sheet. Pay special attention to lines 6 and 7 of the code. These lines control the frequency of the buzzing sound, the length of the buzzing sound, and the delay between buzzes. But before you manipulate any of the code in your script editor, click the Upload arrow in the top left-hand corner of your Arduino Sketchpad window. After uploading, your piezo buzzer should begin buzzing after a few seconds. The code currently does not tell the piezo buzzer when to stop buzzing, so you may want to disconnect your circuit to avoid any annoyance. Experiment with the Arduino code on your own to figure out how to manipulate the buzzer sound and, if possible, terminate the sound after a certain time. This concludes Experiment 2 of Lab 2. In Experiment 3, we will learn to read temperature data from a thermistor using the Arduino, and have the Arduino display the data using an LCD screen. A thermistor such as this one is a temperature-sensitive transducer. You may see it commonly referred to by both terms. Thermistors are used to regulate temperature in home appliances, 3D printers, and engines. Your circuit should also include a potentiometer. A potentiometer is a 3-terminal resistor that acts as an adjustable voltage supplier. You can often find potentiometers in volume controls and position feedback applications. It is useful to test that your circuit is correctly gathering temperature data before incorporating an LCD screen. First, use a multimeter to check the voltage reading across the thermistor. Code shown here has been included so that you can observe the values received from the thermistor directly on your computer. Now to incorporate the LCD screen into the circuit. The specifics of connecting the LCD screen can be found in the assignment sheet, but it is useful to know that the pins are numbered 1 to 16, with 1 being found at this end of the circuit board. To use the LCD screen with your Arduino, you will need to call out a library. Libraries allow you to expand the functionality of the Arduino in various ways. The library we need is a standard library, so you will not need to download anything further in order to make this work. To call on the Arduino library, open up the Sketch drop-down menu in your Arduino Sketchpad window. From the drop-down menu, select Import Library. From here, you can select existing codes or add new, custom codes to the Arduino library. We will select the Liquid Crystal library. The Liquid Crystal library allows us to communicate with a liquid crystal display, or LCD screen. You can visit the Arduino website for more information concerning standard Arduino libraries and how to upload new codes into the library. Your code for Part C should look something like this. If you called on the Liquid Crystal code in the Arduino library correctly, your first line should look like this. Note that the code for Part C looks similar to the Part B code. After writing the code into the Arduino Sketchpad, click the Upload button. If you are successful, your LCD screen should display a temperature reading based on your thermistor's voltage readings. This concludes Lab 2.